So today's class, let's discuss about challenges in machine learning. So one of the major problems in machine learning is it cannot solve ill-posed problems. So machine learning can deal only with well-posed problems. Well-posed in the sense where the specifications are complete. But ill-posed problems are those problems where you do not have a complete specification. And the quality of learning. It depends upon the quality of data. So you need to have a very good quality of data as well as quantity of data when you are using machine learning algorithm. The second challenge is huge data. This is a primary requirement for ML or machine learning. Machine learning requires not just quality data but also large data, and it's essential that that data is not having any kind of incorrect data or missing data in it. The third challenge of machine learning is it requires huge computation power. So naturally, right, since machine learning is using lot of data, huge quantity of data, right, you will need extensive computational resources, right? So and also in order to execute these machine learning algorithm, you cannot really do it easily on a simple CPU. The reason being not just that the algorithms are complicated, and the main reason is you are dealing with huge amount of data when you are running your machine learning algorithms. So that's why it's very necessary that you need to have a GPU, that is a graphical processing unit, or a TPU, that is a tensor processing unit, to execute your machine learning algorithms. Therefore there's a lot of time complexity and high computing power involved in machine learning. The fourth challenge in machine learning is the complexity of the algorithms. So not just that important that you understand the algorithms of the classical algorithms of machine learning, you will also realize that the algorithms can be a little bit complex, right? And there can be a lot of mathematical or statistics knowledge that is required to understand this, or linear algebra concepts are needed in order to understand these algorithms. And therefore it's challenging that you not only choose appropriate algorithms, you should be able to describe your algorithms well, and you should be able to design your algorithms, you should be able to evaluate your algorithms. And normally we also do a lot of comparison of your algorithm with another algorithm. So there's a lot of complexity involved with these algorithms in machine learning. And a very important challenge in machine learning is the bias variance trade-off. So in the later sessions when we are discussing about various models, I'll be talking about this very often. The first thing is, what is a variance? See, variance is the error of the model, right? And when we are executing these or deploying these algorithms or implementing these algorithms, we realize that there is a big problem that we naturally see is a trade-off between bias and variance. You try to improve the bias, the variance comes down, or you try to improve the variance, the bias goes down. So we will be discussing this about in detail in the future sessions. But one of the major problems we also see is overfitting problems and underfitting problems as well. So just to quickly mention what is overfitting is, see, when you are training your data, right, you're training your when you're training your model on some amount of huge data, right? If the training data that you have doesn't have much of a generalization, right, it's very not really generalized for a very it's very specific. Suppose the data is very specific and it lacks generalization, then the model, when you train your model on such kind of data, it is very good on that data only, but it will lack generality. Therefore what happens is, the model works very well on your training that data, but when you are testing it on a new data, it fails. Okay, so when the model works very well on your training data but fails on your testing data, then we say that the model has the problem of overfitting. So that means the model is specifically being trained for a particular data only. There is not much of generalization. Another problem that we see is just the opposite, underfitting problem. Underfitting means the model here, right, fails for the training data, right? It fails for the training data, and that can be because just the opposite, it must be having a good generality, right? So that is called as underfitting problem. So in the your model is you have developed, you have trained it, and you're seeing that when you test the performance, it is failing on that training data. So then we say that the model is underfitting, right? So it's very important that you try to balance when you're trying to develop your model. We need to achieve a good balance between overfitting and underfitting. So we will see all of this in the later sessions. So overfitting, underfitting, we will see this in the second module and third module and so on. It's one of the biggest challenges in machine learning, and how we can overcome these problems we will see with respect to particular algorithms in machine learning. So that was about the main challenges of machine learning, and in the next session we will discuss about the machine learning process, that is CRISP-DM. Thank you, and please subscribe to our channel. Thank you.